Hello everyone. In the previous lecture, we have discussed about the SOP and POS canonical forms. So SOP is sum of products and POS is product of sum. In canonical forms, we have talked about there is a Boolean function, and let's say if I am saying there is a Boolean function f which is defined over three Boolean variables a, b and c. Now over these three Boolean variables, how many Boolean functions can be defined? So we have already seen total number of Boolean functions over, let's say I'm saying n Boolean variables. We have seen this is 2 to the power n, right? But in this lecture, we are going to talk about if any specific kind of functions has been asked, not the total number of overall functions, then how we will calculate. So let's think like if there is a question given like this. So I'm giving you a question. Let's say if I ask you how many Boolean functions are possible how many Boolean functions are possible with, let's say, two or three variables. So let's consider with three variables. So if I say this, you can apply this formula 2 to the power 2 to the power n. But now I am specifying further conditions such that, so I am not asking the all will be 2 to the power 2 to the power 3, that is 2 to the power 8, right? But I'm asking very specific such that there are exactly, let's say I'm saying 2 minterms or 3 minterms or 4 minterms. So consider there are exactly, let's say, 3 minterms. Minterms and max terms I have discussed in the previous lecture. So I think you have gone with that lecture. If not, then you can check it. Right, so the question mark is here. How do we solve this particular question? So what exactly we need to do is, if it is given that there are 3 Boolean variables, then we know that the total possibilities, so let me draw that. There will be 8 combinations of 3 Boolean variables. There is no doubt in that. So let's say 3 Boolean variables I am considering A, B and C. Okay, and the combinations are 0 0 0 0 1 1 1 and 1. So there is 0 0 1 1 0 0 1 1. There is 0 1 0 1 0 1 0 1, right? Now here we are defining function. So let's say there is f. Now we are interested in such functions. The total number of functions out of these three Boolean variables we can define 2 to the power 2 to the power 3, 2 to the power 8. But we are counting here where exactly 3 minterms are there. 3 minterms means out of these 8 places, there has to be only 3 places, those are high, right? So any 3 place. So maybe the very first place is high, second is high, third is high, and rest of the places are low. That means these 3 are 1 and remaining are 0. Or this is 0 but this is 1, this is 1, this is 1. Any 3 place should be high. So this is the question. You know that. How we can find out? It is very easy. So total such functions is equal to, out of these 8 we need to pick any 3. So we can say 8C3. The total number of such functions would be 8C3. So if we solve it, we know that it is factorial 8 divided by factorial 3 into factorial 8 minus 3, that is factorial 5, right? So we can solve it. Factorial 8 is 8 cross 7 cross 6 cross factorial 5 divided by, it is 3 cross 2 and it is factorial 5. So we can cancel this factorial 5 with this, right? 3 cross 2 will be 6. So the total number of such functions are 8 7 ja 56. Okay, so the total number of such functions would be 56, right? So any such kind of questions can be framed. Let's say 2 Boolean variables are given and find out the total number of count of such functions. Those are having exactly 2 minterm, 3 minterm and so on. So I guess you will be able to solve such kind of questions, right? Now there can be n number of minterms and max term, you understand that, but there is a specific type of function we consider as neutral function. So let's put it down. What is neutral function actually? If in a function the number of, so I'm writing neutral function, sorry, what is a neutral function? In which the count of min term and max term are equal. So the count of min term is equal to the count of max terms. So any such function we'll consider as neutral function. Okay, right? So with this I'm closing this lecture. Thank you.